Hello everyone. Thank you for attending this KBC EMEA eCopper, IP and Power over Coax and UTP webinar. My name is Craig Kennedy and I am the Technical Solutions Architect for KBC Networks EMEA region. We also have Janine Tucker, Head of Marketing, and Luis Angulo, our Commercial Director. We will be recording this webinar and making it available to you at the end in a separate email, along with some other information. As you're aware, many parts of Europe and Asia are still under some form of lockdown, and for KBC the same is true. However, I want to assure you that KBC Networks are still producing even under these difficult conditions, and our teams in the USA, UK, Dubai, Mexico and China are all available as usual to help you. Shipments from our USA and China facilities will continue as normal, and there is still selective stock available in Spain for immediate delivery. KBC Networks has been trading now for around 25 years, and our eCopper line was recently awarded the Buyer's Choice Award from ASMAG. For those of you who have not attended our webinars before, KBC Networks have 6 main product lines. Our IP range, which includes our network switches, SFPs and fibre media converters. The gem in our portfolio is ThruLink, a hardware VPN. Our wireless solutions, analog fibre optics, eCopper, which is our IP over Coax and UTP, and finally our remote power solutions. Today's webinar focuses entirely on the eCopper, IP over Coax and UTP. But before we begin, I would like to briefly go over the media converters a little more, and eCopper is part of our media converter portfolio. As a manufacturer of transmission solutions, we cover a very large array of different product types and groups. One of these groups is media converters. When you hear the term media converter, many of you will immediately think about IP over fibre, and our own IP over fibre products fall under the media converter banner. However, we also provide IP over wireless, 4G solutions, and of course IP over coax and twisted pair. Other webinars will cover fibre and wireless solutions, but today we're going to focus on just the eCopper, IP over coax and UTP. So, eCopper, what is it? Well, simply put, eCopper is a media converter designed to allow you to send IP and power down existing coax cable or 2, 4 or 8 wires of UTP cable, or any pair of wires that you happen to have available. This can include non-standard types of cable as well. There are 3 main reasons to consider using KBC Networks eCopper as a solution. You have an existing analog system and you need to upgrade the entire system to a new IP-based system. But running new cable is going to have cost. Not only the cable itself, but also the labour to install the cable and any business downtime resulting in lost revenue. So if you have an entire office block, for example, or a shopping mall that's running coax and perhaps twisted pair cabling for alarms, then it makes far more sense to reuse the existing infrastructure with eCopper. You might also have come across cable runs that go beyond the normal 100 or 200 metres, coax or UTP, and you again need to extend IP across these greater distances. Or it could simply be that you have a new install that has to be Cat6 cable, and the distances are 300, 400, 600 metres even, and your initial thought would be to use multiple repeaters. Well, eCopper can work at up to 800 metres, coax or UTP, and at distances up to 300 metres running just a single pair of wires. Of course, like anything related to transmission, the distance can be more or less depending on the cable type, the quality of the cable, and if you need to send power. Leading me on to our 3rd reason, power. eCopper can provide PoE power and PoE plus power up to a maximum of 30 watts via the coax or UTP. So where again you need to upgrade the older analog system to PoE or PoE plus devices, but you only have 12 or 24 volts DC local power, which was typical of an old analog system, then you can simply ignore the local power, connect the eCopper and power your devices through the existing cable. eCopper is a great solution when you need to upgrade an existing analog system but reuse the existing cable, whatever that cable is. It can also provide you with the distances that go beyond the normal 100-meter limitations in new installations without the need to use fibre or wireless, which can't provide you with the power needed for the new IP devices. You can also consider this a green initiative. We are, after all, recycling by reusing the existing cabling. Here we have a few images of the smaller one-channel units, just to give you a better idea of its physical size, which, as you can see, it has a very small footprint. We have the IP over UTP unit and we have the IP over coax unit. Both look identical, but of course one has a BNC connector. You'll notice that neither of them have any power connectors on them. Remember, the power comes down the cable to these units. Also note the LED status indicators on these units. You have a power LED, which will light up when it gets power from the receiver. Then you have a link LED, which lights up confirming the coax or UTP cable between the transmitter and receiver is now connected. And then you have an Ethernet port, which only becomes active when you actually connect the end device. I have a few basic drawings that will show a before and after the use of eCopper, just to give an idea on the connectivity of these units. In this simple drawing, the top is a basic analog camera connected via coax to a DVR. I'm sure you've come across this sort of thing at some point, and many systems are still like this now. You need to upgrade the camera to an IP camera and connect it to an NVR. We simply introduce the eCopper units as you see here. The coax distance remains the same. All we've done is connect the eCopper transmitter to the camera and the receiver at the NVR side. And now you have an IP capable system operating over coax cable, and the receiver is also able to provide power to both the transmitters and the cameras. This example is almost identical to the previous one. However, a tip here. What we've done is we've used a coax T-piece to split the coax cable at the camera side and connect a second transmitter. Doing this, you can actually have multiple cameras or other devices. I recently tested this exact scenario, but I actually split the coax 3 ways rather than 2, powering a NEDAP door controller, Pelco camera and an iPhone touchscreen display, all over 100 meters of coax. One coax. In this final example, we're showing an old phone system. Typically this would be a 4-wire system running throughout a large office complex. Again, replacing the older cable with new Cat5e and Cat6 is costly in terms of time and disruption to business. Now you can see the simple transition from the old analog system to the new IP system. At each termination point, we put in place our IP over UTP transmitter using 1 or 2 pairs of wires, and to each transmitter we connect the IP device, be that a phone, camera, access control or intercom. Any IP device will work, and remember you can do this over 1 pair of wires. Each of the transmitters is connected to the 16-channel receiver unit here, and this 16-channel receiver is responsible for providing both IP communications and power to each of the transmitters, which in turn provides PoE or PoE plus power needed for the connected device. So in this example, to replace an old analog system is simply a matter of connecting the transmitter and the receiver to the existing cabling and plug in your new devices. So in this video demonstration, we have an iPhone intercom system running over 1 pair of wires, 100 meters of 1 pair of wires. We have power coming up and into this receiver unit here. The power is then sent down the 2 wires, 100 meters, and into this device powering the transmitter. The transmitter then provides PoE power to the actual door panel. The whole system works seamlessly. You wouldn't know you were running over 2 wires, as you can see from the video clip. A very simple solution. Now, if you're converting a system to IP and the existing cabling is coax based, then you can realistically expect to get PoE power at up to 500 meters and PoE plus at 150 meters using a standard 48 volt DC input at the receiver side. If you up this to 54 volts DC, you should get closer to 700 meters with PoE and 300 meters with PoE plus. And again, at 57 volts DC, probably another 50 to 100 meters. So theoretically, you could get 800 meters over coax with PoE and 350 meters over coax with PoE plus. And with UTP, the figures will be slightly less depending on the cable type and how many pairs of cables you're using, and of course the input voltage. Our chart here uses very conservative numbers as a guide, but as you can see, fewer pairs on the UTP cable will still give you power. And you saw that in our video as well. But the distance is reduced. Now if you need to go further than these distances, but you don't need to send power down the cable, so you've got local power you can use, you only want to send IP, then you can use our standard non-PoE version of transmitter and receiver and go significantly further. Lastly, one of our more interesting projects was multiple lift shafts in a building and the need to upgrade all the existing tech to IP. The actual cables used were flat cables rather than twisted pair cables, and the customer had already tested several other manufacturers' IP over UTP solutions with mixed results. But the one result they all seemed to suffer from was crosstalk, due to the levels of interference found inside the enclosed space of an elevator shaft, and the fact they're using flat cable. However, they then tested using our eCopper and found no crosstalk at all, and it is now their go-to solution for all similar projects. So I can confidently say our units are immune to typical interference found on Coax and UTP systems. I just want to briefly go over some of the acronyms involved here. I haven't used many of these acronyms during the presentation, but there are quite a few related to the technology, so I think it's good that you understand what they are. Obviously, UTP and STP you've probably come across as unshielded and shielded twisted pair cabling. But POC and POW are specifically related to this type of technology, referring to power over coax and power over wire. Again, PoE and PoE Plus, I'm sure you know, though the actual power values do seem to depend on the product and the manufacturers. But for the record, eCopper can offer PoE at 15.5 watts and PoE Plus at a maximum of 30 watts. And then lastly, EOU and EOC. These are Ethernet over coax and Ethernet over UTP. They're pretty straightforward to remember, but if you're not sure, you just send us an email or ask us and we'll help you. Okay, so here we have the Lego bricks that make up the eCopper solution. This is the coax range. Starting with the transmitters, and remember the transmitters go at the remote location where the camera or access control or other IP device would be. In this presentation, we've color-coded the product model numbers to keep things simple. Blue represents coax or UTP. Red is transmitter or receiver, while the green here is for IP without power. These are the ones used for longer distances without sending power. We have 3 EOC transmitters available. This particular unit was designed to fit inside a camera housing or a dome camera with the cable connectors rather than the RJ45 sockets. Then we have the standard single channel unit. It's exactly the same size but without the flying leads. And remember, none of these units have a power connector on them because the power comes from the receiver, making installation much quicker and simpler. And the status LEDs on the units will tell you everything you need to know during the installation. And then lastly, the 4-channel transmitter, which does need a local 48 to 57 volt DC power supply, but will allow 4 PoE or PoE Plus devices to be connected and all data be transmitted down the same single coax. So where you might have had a single analog camera, you can replace it with 4 IP cameras, each with up to 30 watts of power, and send all 4 cameras down a single coax cable to the receiver unit. So that's the transmitters. Next we have the 4 available receivers, which I think are fairly self-explanatory. The single and 4-channel receivers both take a 48 to 57 volt DC input and provide power and Ethernet down 1 or 4 coax cables. And the 4-channel has both an Ethernet and an SFP port, so if you need to send it down a further 100 kilometers of fiber, we can do that all within the same unit. And don't forget, we also supply SFP modules. The 8 and the 16-channel receivers are 1U high 19-inch rack mount units and provide PoE at 15.5 watts or PoE Plus at 30 watts down all individual channels to the transmitters. Each unit also comes with 3 gigabit Ethernet ports to feed the information into an NVR and other networks simultaneously. So there we have the Lego bricks that make up the eCopper IP over coax solution. And here we have the IP over UTP Lego bricks. Now I won't go into too much detail here. These are almost exactly the same as the IP over coax units. They simply don't have a BNC connector. Instead, they're using an RJ45 connector. If you're using 2 or 4 pairs of wires, we suggest using a standard RJ45 connector. But if you're going to use a single pair of wires, we will provide you with a 2-pin to RJ45 converter. Crimping 2 wires onto an RJ45 is not a fun task. Having just gone over the multiple Lego bricks for the eCopper range, it only makes sense we include the model number configurator. It looks far more complicated than it is. Most of our products use the same format of configurator, so if you plan on using KBC products, it's a good idea to try and familiarise yourself with the format. The individual components may be different, but the process for all of our products is exactly the same. But don't worry if you struggle to understand it or aren't sure if it's right. Just send an email to emea@kbcnetworks.com with your questions and we'll select the right model for you. I'm now going to go through a few typical system examples that I hope will give you a better idea of usage. Starting with this simple one-to-one solution. Here we have 3 remote locations. This could be a car park area, for example, where they had multiple analog cameras all running on coax. We have a PTZ dome camera using our in-dome module with the fly leads. This is connecting onto the existing coax cable. And at the other end, where the MVR or the control screen might be, is a single channel receiver unit. The receiver has a 48 volt DC input. Power is sent to the transmitter and then PoE power to the camera. Remember, up to a maximum of 30 watts. These other 2 cameras, again, powered from the receiver over the coax, they all come back into a switch which in turn feeds them all onto the network or NVR. Nice and simple. Now this example is using existing coax cable, but it could just as easily be a system using 4 wires or even just a Cat5 cable, or possibly a single pair of wires. Either way, to upgrade this small system is simply a case of removing and installing the new cameras, add our small transmitters and receivers, and you're now running a full IP system over old cables with power. Now we have the same 3 locations as before, with the same transmitters as before, but this time we're using a 16-channel receiver. The receiver is now providing power and Ethernet to all 3 locations, and we're using 2 of the 3 gigabit ports on that receiver. One goes to the NVR and the other into a control room network. We also provide our optional eCopper management software here. Now this isn't required for the configuration, but it comes at no additional cost. A little later we're going to talk about the software management system. This would be the ideal way to upgrade an existing analog system over a period of time. So this could be a large shopping mall where the existing analog system needs to run alongside any new system temporarily. Use of the 16-channel unit means the upgrade is quick and simple. Replace the camera, connect it to a single channel transmitter, connect that to the existing coax, and then down at the control room side, simply connect the coax to the new 16-channel receiver and your new camera should come to life. Now we have a more detailed and integrated solution. This time it's a multi-site system. So here we have 4 remote locations, again over coax or UTP cable. These 2 cameras are being powered via this 4-channel unit, whilst these 2 from this 4-channel unit. And both are connected via a standard Ethernet cable to the control room network. But now we have a 3rd location. So you might be looking at a power substation, for example, or a car park outside of a town or a city. But here we have yet another 4-channel receiver, but this one is linked via an SFP port over fiber back to the control room. So eCopper is not only good for using existing cable in a localized system, but can also be used to bring local systems from remote locations back to the control room. So eCopper is not only good for using existing cable in localized systems, but can be used to bring local systems from remote locations back to the control room. So now we're utilizing the existing coax or UTP, as well as making use of any fiber we had. And lastly, an example of a larger scale eCopper system. For example, this would be a casino or a shopping mall where they have multiple 16-channel receivers in a rack. all connecting to the existing network, feeding into the MVRs and the control room networks. Each one of these 16-channel receivers can provide power to 16 individual transmitters. And if you're on coax and the power requirements are not too high, you could double that to 32 by using our T-piece. If you have power at each of the 16 remote points, you can also use a 4-channel transmitter and pull back up to 64 remote cameras all over coax installed 20 years ago. So now onto the eCopper management system. We include this software with our product at no extra charge, but you don't need to use it. Usage is optional, but you have it available. A very simple software package for installation on one or more Windows-based computers, offering you remote monitoring capabilities. You simply add the remote device into the software and are given a live view of what the front of the actual unit's LED indicators show, as you can see from this image. You can also view the actual live power information on each channel. You can see here the current being used, the voltage being sent to the transmitter from the receiver, and the total power in watts being used by the device connected. There is also a remote power feature that allows you to power down the remote device by simply turning off power from the receiver to one of the channels. This in turn powers down the remote device at the same time. Great when you have an issue with the end device and need to power cycle it. And note, if you link up the management server to a control room in another part of the country or world, using our ThruLink for example, you can still use this feature. Then lastly, we have a log of all activity, from where the user logs in, from what remote client they're on, whether a device was powered down, etc, etc. A very simple software package that we provide for free. So here are a few key things to remember about our eCopper products. eCopper has built-in power protection, checking the power constantly across each link in the system to ensure stability, and no power is sent to the transmitter until the receiver detects the transmitter has been plugged in. If there's a short or the cable has been unplugged from the transmitter, the receiver will immediately stop sending power until that transmitter is reconnected or the short is repaired. So to summarize on the eCopper line, you can upgrade any existing analog system to IP by reusing the existing cable, coax or twisted pair. eCopper can offer increased transmission distances over the existing cable limitations. And we can offer you power to all of these remote devices, so you don't even need local power. The entire range is industrial grade, as are all KBC products, making the units ideal for use in outdoor housings. The eCopper has been designed to be immune from interference and crosstalk. It also offers power protection over all links within the system and comes with a simple software management tool for monitoring the system without the need for site visits. This is perfect for elevator installations or mid to large systems with bundled cable runs. The single channel units are extremely small, making them perfect for use inside camera housings or domes, or behind wall panels in very tight spaces. And with 1, 4, 8 and 16 channels available, we can offer nearly unlimited expansion. And the plug and play design means adding new devices is very simple. And of course, we offer competitive pricing on all the Lego bricks in this range. To date, the eCopper solution has been used in all types of systems, from casinos and elevator shafts to parking lots, as well as systems where the need for longer distance over UTP was the issue. But if you have a project and are not sure which product set to use, just contact us or your local office and they will help guide you to the right solution. We have different warranty terms on different product ranges. All of this information can be found on our website, but essentially, all of our standard digital fibre products come with a 5-year warranty. Though I should mention, we have got fibre equipment in the field that's been operational now for over 15 years. For the eCopper and media converters, it's 3 years, and it's 2 years for our ThruLink and wireless. And again, we have several thousand ThruLinks installed since 2009, still working today. The solar is a little different, where we guarantee delivery at least 90% of the capacity for 12 years. KBC Networks have a very good reputation for giving fast, high levels of support, often going over and above the standard support expectations. We will always do our best to respond to you as quickly as possible, and we're always on hand to assist with product selection guidance, system design and product support. Most of you probably already have my contact details and know how to reach me, or you can email emea@kbcnetworks.com. Thank you for attending this webinar, and thank you for giving us the opportunity to show you eCopper.